twice as much light as f22. Let's continue talking about f number. Now, something that is sometimes confused or used as a synonym for f number is f-stop. Now, again, f-stop goes back to the days of manual settings on cameras, and you use the f-stop ring on the lens to set the aperture. Each f-stop means a factor of 2 change in the exposure. That's equal to changing the shutter speed by a factor of 2, for instance, or setting the ISO by a factor of 2. So again, looking at this diagram, we have that f1.4, 1.4 squared is 1.96. Compare that to f2, 2 squared is 4. Now here I didn't divide by 2. But notice that 4 is about twice 1.96, which means that f2 has half the light gathering power of f1.4. We look at 2.8. 2.8 squared is 7.8. 7.8 is about twice of 4, which means that f2.8 has half of the light gathering power of f2. And similarly, f4 is half the light gathering of f2.8. f5.6 is half of f4. f8 is half of 5.6. So this is how you do these computations. And changes changes in f number, which change the exposure by a factor of 2, are what the automatic stop points are usually set for on the lens, and that's why they're called f-stops. It's where, as you're sliding through the f number settings, where it clicks into place and stops. Okay, now, having pulled all of that information together, we have an interesting chart here, and that I have a whole set of camera settings now listed on this page, where each of these camera settings ends up producing exactly the same exposure in the photograph. ISO 200, f16, shutter 1/200. That's using the f16 rule, for example. But that's the same as ISO 400, f16, shutter 1/400 seconds. Or it's the same as ISO 200, f22, and shutter of 1/100. Or down at the bottom, we have ISO 200, f5.6, and shutter of 1/1600. The shutter is 1/1600th of a second there. So all of those groups of settings have exactly the same exposure. So you can think of it like this. You can compute that exposure by taking the ISO number, multiplying it by the shutter speed, like 1/200th of a second or 1/100th of a second, and divide by the f number squared. And if you do that, and if the number comes out the same for different choices of ISO, shutter, and f number, then the exposures are the same. So what it means is that when we're using the camera in manual mode, we have a whole set of settings to choose from. And then how would we choose, and why would we choose one group of settings over another? So just to convince you that two rather different settings give you exactly the same exposure, I compare the two photographs here. Photograph on the left is taken at ISO 200 with an f22 and shutter of 1/100 second, and compared to the photo on the right, which is also ISO 200, f5.6 and a shutter of 1/1600th of a second. The two photographs look almost exactly the same, except the cloud patterns are different because there was a few seconds in between the two photographs while I was computing the equivalent exposure settings. Okay, now, speaking of computing, typically the camera solves this problem for you in that your camera, most pro DLSRs and even semi-pro ones, have built-in exposure meters. You set the ISO and you can cycle through shutter or aperture until the camera tells you that the photo is approximately properly exposed. So when you're looking at your exposure meter, you might see it either by looking into the lens, or you might see it by looking at one of your liquid crystal displays on the top of the camera, for instance. You see this meter, The meter on the top shows a proper exposure according to the camera's calculation. The light meter in the middle shows a setting which is one stop underexposure, and the setting on the bottom shows a one stop overexposure. So, but again, this is letting the camera do the selections, and sometimes you actually want to set it to be either underexposed or overexposed, again depending on what you're trying to do with the photograph. And we will talk about this in more detail in subsequent lecture presentations. Now, each f-stop means a factor of 2 change in exposure. Remember that. F-stop means a factor of 2 change in exposure. And an f-stop is not the same as f-number, although people sometimes use them to mean the same thing. Okay, now what's the effect of choosing different f-numbers? The focus ring on the lens is set to a specific distance from the camera. So you set up your model, focus on your model. Now, there will be a certain region around that focal distance where everything within that region will also be in focus. But if you go too far behind the model or too far in front of the model, then things will become out of focus. Depth of field refers to the range of distances in front and behind the exact focal distance for which the objects appear to be in focus. Large apertures, that is, smaller f-numbers, have smaller depths of field. Okay? So this means, for example, that f2.8 has a smaller depth of field than f11, which has a smaller depth of field than f22. Now, if you want to blur the background, which you frequently do when you're shooting portraits because you don't want other items in the photograph to interfere with your appreciation of the person you're trying to photograph, you want to create a depth of field that contains only your subject and blurs the background in portraits. Use a telephoto lens or a zoom in and zoom in on your subject. Move as close to your subject as possible. Move the subject away from, that's closer to the camera, away from the background elements that you want to blur, and use the widest aperture that you can. So, for example, f2.8 or 1.8. And many cameras have a button on them which gives you a depth of field preview, which of course reminds me to mention to you that it is really worthwhile to read through your camera's manual and practice what different buttons do on the camera. Learn how the controls on your camera work. It will dramatically improve the quality of your photography. Okay, now here's a photograph with a depth of field comparison. Two photographs, one taken at f16, where just about everything in the photograph is pretty sharp. The other taken at f1.4, where you can see that the background begins to blur. In fact, the background begins to blur a relatively short distance behind the main subject, which are the leaves of the tropical plant. Okay, now it's time to practice. So let's get into this and have some fun.